Greetings, I'm Squared here, and we are going to talk about linear functions today. So we've been talking about functions. Remember, a function is a rule where every x has exactly one y. And so we want to talk about linear functions. So linear functions, because they're called linear functions, we know they're already a function. And the first four letters spell the word line, so we know that's what it's a picture of. So linear functions are functions with a constant rate of change, which we call, remember what that means? That means slope. Constant rate of change means slope, and it's consistent. It always goes up the same amount no matter where you are on the line. So you're used to y equals mx plus b. With it being a function, we're going to use the function notation, so we're going to use f of x. Remember, we say that f of x. We don't say f times x because that's not what it means. We say f is the name of it, x is what we're putting in, and then this is what we're getting out. So it's kind of like our little machine. Put x in, and this is what we get out. What kind of lines are not functions? Because not every line is a function. Can you tell? Well, if every x can only have one y, then vertical lines are the lines that are not functions, vertical lines, because it says x equals like 5. Well, x equals 5, for every x, it's 5, but then it has an infinite number of y's, so it can't be a function. So the first thing, we're going to do several things today, but the first thing we're going to do is decide by looking at a picture, which shouldn't be too hard, or an equation, if it's linear or not. So if it's a linear function or not. You can pause your video and kind of stare at those for a minute. I'm going to tell you, but then you can kind of decide on your own what makes a function linear. Okay, well, if I look at all these functions, I notice that I have an x. F of x equals something with x. It's being multiplied by a number. It's being multiplied a number and then subtracted. It's being multiplied by a fraction, still a number, subtracted from a number. It's being added and divided. So we've got adding, subtracting, multiplying, and dividing going on. Just x, though. Nothing other than x, nothing weird happening to x. You'll notice over here on our nonlinear functions that I have an x squared. I have an absolute value with an x inside it. I have an x that's an exponent, and I have an x that's got a cubed on it. Those are not linear functions. So all of these make a line. That's a positive slope, and a positive slope. This over here, these aren't lines. This is called a parabola. I can tell it's a parabola because it's got an x squared on it, and that's a quadratic function, so it's going to look like that. This has an absolute value around it, so I know that that looks like a v. This has an x as an exponent, so I know it's going to look like that. It's going to be it's called an exponential function. It's kind of like a little curve there. And this is a cubic function, and it looks something like that. So it's really to your advantage that you are able to look at an equation and know the picture in your head. Because if I ask you to graph something and then if I ask you to graph this and you find it's a line, that's a really common mistake, then you'll know, hey, I did something wrong because that's supposed to be a V and I got a line. So it's really important to be able to look at an equation. So one of our goals this chapter is you can look at an equation and identify. You can tell which ones are lines and which ones are not lines. It's pretty easy when you have a graph. These are lines, these are not lines. Again, that's an absolute value, that's a quadratic. So I'm going to leave this part up to you. Think about it. How can you tell if a linear function is, if a function is actually linear? And we talked about that. Nothing weird going on with x. X can't be squared or square rooted or absolute valued. It can just be a pretty little x. Okay, so that's our first goal, right? Can you look at an equation and tell if it's linear? Can you look at a graph and tell if it's linear? Our second goal is to evaluate functions. So when we evaluate a function, we're actually going to be finding most of the time, and in this chapter, that's all we're going to do, but when you move on in math, it doesn't always happen this way. We're going to actually be finding a numerical value, a number. So, like I said, it won't happen that way always, but here, that's what we're going to do. So we're going to substitute the value that they tell us, the new input, into our equation so that we can get an output. So it says f of -3. Notice it says f. F is telling me which one to use. I have to go to the function whose name is f. This one's name is f. This one's name is g. This one's name is h. So I have to go to the one that says f. And then it says, hey, put -3 in for x. Tell me what you get out. So I go over and I say, okay, I'll put -3 in and tell you what you get out. So -2 times -3 is 6. Then we have to subtract the 8, and we get a -2. So there we go. F of -3 equals -2. Okay, so I've got to do that for g of 10. What is g of 10? That's how you say that. Well, I've got to go to the g function, and I've got to put a 10 in for x. And I've got to figure out, well, 10 plus 5 is 3. 15 divided by 3, remember, a fraction bar means division, is 5. So I just found g of 10 to be 5. If that's my g of x, then that is my g of 10. Okay, h of negative 16. So this time I have to go to h. It says 1/4 of negative 16 plus 3. Well, 1/4 of negative 16 is negative 4. And if I add 3 to that, I get negative 1. Okay, this one's got a little addition going on. I first have to find g of 1, then I have to find f of 0, and then I add them together. So I'm going to have an addition sign. So what is g of 1? Okay, well, I go to my g function, and I put my 1 in. Then I have to go to my f function and put my 0 in. So 1 plus 5 is 6. 6 divided by 3 is 2. Negative 2 times 0 is 0. Minus 8 is negative 8. And 2 minus 8 is negative 6. So that is what g of 1 plus f of 0 equals. Okay, that's how you evaluate. Now we're going to take those two things we just learned about, the, hey, is this a line, and hey, how do you evaluate, and we're going to use that information to graph. So whenever I look at it, I say, is that a line? Yeah, nothing weird going on with x, multiplied by something, subtracted. And hopefully you remember this is the slope, this is the y-intercept. We're not going to graph it that way like we did last chapter. We're using tables and evaluation. So we're going to get practice evaluating and then some more practice graphing. So you can choose any numbers you want. I'm going to choose a negative 2, I'll choose a 0, a 1, a 3, a 4. It doesn't matter what you choose. So if I put a negative 2 in, remember I'm evaluating. So I'm finding f of negative 2. F of negative 2 says negative 6 minus 4. That would be a negative 10. Now I'm going to find f of 0. Oh, let me graph the point first, because then I want to show you the connection there. This is our x. This is our f of x. It's like our negative 2, negative 10. That's a point on our graph. So we're going to go negative 2 and negative 10, and that's our first point that we're going to graph. 0, if I find f of 0, this is what I get. So 0 minus 4 is negative 4. So if I'm at 0, I'm going to go down 4. Again, that's my y-intercept, which most of you probably figured out because you can see the mx plus b right there. So a little bit quicker now. If I put a 1 in, I get 3 minus 4. Right? 3 minus 4 is negative 1, so I'm going to graph 1, negative 1. If I put a 3 in, I get 9 minus 4, which is 5. So 1, 2, 3, 4, 5. And if I plug a 4 in, I get 12 minus 4. Minus 4, which is 8. And so I would go to 4, 8, and make my little dot. And then I'm going to connect all the dots. And that's how you can graph an equation of a line using evaluation. Just plugging in. It's a really important skill. Whenever I am stuck with maybe something I don't know what it looks like, I plug x's in, get my outputs, and graph a bunch of points. And it can really make a difference, especially if you don't know what that function looks like. Okay, we'll just do negative 3, negative 1, 0, 2. We'll just pick some points. So this one doesn't have anything multiplied by x, so it's just negative 3 plus 7, which is 4. Negative 1 plus 7, which is 6. 0 plus 7, which is 7. 2 plus 7, which is 9. And I would just graph those points. So negative 3, remember these are my points. Negative 3, 4. So I'm going to go over negative 3, up 4, make a little dot. Negative 1, 6. 0, 7. And 2, 9. And I connect them. And that is my line. Okay, now I wanted to, I'm asking, what is the domain and range? Do you know what the domain and range of a line is? As long as it's not vertical or horizontal, it goes left and right forever. So that means my domain would be all real numbers. And my range also goes down forever and up forever. So my range would be the same. I'll write my range in interval notation to remind you. We get negative infinity to positive infinity. So anytime you have a line that's not vertical or horizontal, the domain and range is always going to be all real numbers. So keep that in mind. Left forever, up forever, down forever, right forever. When I have a fraction as a slope, or that number in front of x, try to be smart about what numbers I pick. If 2 is the denominator, then I'd only pick even numbers because it's going to be divisible and I won't get a decimal, so I won't have to graph like 5.2 or 5.7. If it was divisible by 3, I'd only pick numbers that were, if the denominator was 3, I'd only pick numbers that were divisible by 3. So with that in mind, I'm going to pick a -4, a -2, a 0, and a 2. Because those are all even numbers, and I know I can take half of them, because that says take half of it and then add 5. So half of that is -2, half of that, half of 0 is 0, and half of 2 is 1. So then when I take half of it, and then I just add. And then I can graph the points. So -4, 3, 1, 2, 3, 4, 1, 2, 3, -2, 4, 0, 5, and 2, 6. And I connect the dots. So that's just a quick little shortcut. Then you don't have to worry about decimals. And again, what's the domain and range? Domain and range are both all real numbers. Okay, which leads us to the next thing, which I believe is our final thing. Yes, it's our final thing. Okay, so how do you write an equation of a line if you're given a table of points? Well, to write any equation of a line, we have to have a slope and a point. The easiest point, or I don't know if you remember, is to find your y-intercept, which is our b. When does that happen? That happens when x is 0. So whenever I'm looking, I always look for my x is 0. So there we go. I know 0, 5, -5 is my b. Well, what about my change in my slope, which is change in y over change in x, or y over x, our little formula? Well, when you're doing it here, you can just kind of say, hey, how did this change? Oh, I went down 4. Well, how does this change? Oh, that went down 4 too, down 4. I'm subtracting 4 each time. That's my change in y, so I'm going to put change in y up there. Well, what's my change in x? Well, +1, +1. I'm going up 1 each time. So my change in x is 1, which means my slope is -4. So if I know my slope is -4 and I know my y-intercept is -5, that's this one right here, it's the same one, then I know my f of x, my linear function, would be slope times x, then plus the y-intercept, -5, because it's our y-intercept. Now when you're graphing, when you're writing these equations, you always need to have it in f of x equals mx plus b form. You have to have it like this, but you could still get it like this and then get the y alone and change it to f of x. So it doesn't matter which way you start, but at the end it needs to be like this. So whenever I'm looking at it, the first thing I do is say, hey, do I have my y-intercept? Because that makes it super easy. I do. So now I just need to find my slope, right? I know my f of x is going to equal something times x plus 3, because my y-intercept is 3. Well, what's that something? So now I have to find my change in y over my change in x. In higher math, these little triangles mean delta y, delta x, which is the same thing as change in y and change of x. That's why I'm writing it like that. It's just easier than saying change of. Okay, so what's happening here? I just added 2, and I added 1. So, yep, up 2, up 2, up 2, up 1, up 1, up 1. Okay, so my change in y was 2, my change in x was 1. Be careful. When this is on the bottom, people want to put the change in y on the bottom because this f of x was on the bottom, so just be careful that you don't do that. So there's my equation. It's pretty simple, pretty easy. Okay, so what happens if you don't have the y-intercept? Notice there's no 0 there. Now I know it's right here. Look, I know it would go right there because I see that it goes -3, -1, and then there's nothing, and then 1, 3, 5. So I kind of put that little block in to kind of say, hey, that's where it goes. What can I do? Can I find that without doing like the algebra that we did last chapter? So again, I'm going to find my change in y over change in x. So it looks like up here I'm going +2 each time. +2, +2. Yep, +2 each time. So that's my change in x. So that's the 2. And then I'm going to do my change in y. It looks like -2 each time. Okay, so my change in y is -2. What do I get? I get a -1. Okay, so I know that my slope now is -1. You can put a -1x. I'm just going to put a -x. But then I need to plus my y-intercept. Well, if I know that for each time I go down 1 for y, I go up 1 for x, then if I'm going up 1 for x, I'd get my 0, but I've got to go down 1 for y. Well, that's 10. And is 10 between 9 and 11? Absolutely. So now I know that my y-intercept is 10. That's one way to do it. We learned a different way last chapter, but that's an easy way to just kind of figure it out from the pattern. I like to do it that way. So again, first thing I do is, hey, is there a y-intercept? Nope, but it would be right in the middle of negative 2 and 2. So let's find the slope. What's my change in y? Okay, that's plus 1. Now I have a plus 2, and then I have another plus 1. So now I've got to be careful. So we've got a plus 1. What happened there? A plus 2. Okay, so it was 1 over 2. Then I want to make sure it's linear, because every once in a while they make them not linear. Okay, here we go. That's plus 2. That was my change in y. And what happened here? That was plus 4. So is 2 over 4 the same as 1/2? Yeah. Okay, so my slope's 1/2. Up 1 over 2. Okay, y equals 1/2 x. Now what's my y-intercept? Well, remember, my change in y said every time I go up 1 this way, I'm going up 2 that way. Well, up 2 would give me a 0, but I'm going up 1, so I have to go on my y, so I have to get a 7. So it would be plus 7. Now again, if you don't like trying to figure it out that way, you can go back to your plugging it in. Remember, we just pick a point, like let's pick this point and say 9 equals 1/2 times my x plus b. Remember that little thing we did? And then what's 1/2 of 4? That's 2. So now I have 9 equals 2 plus b. So I subtract 2 from both sides, and 9 equals 7. 9 does not equal 7. 9 minus 2 is 7, which 7 equals b. Okay, and we already knew that. But just saying. All right, over here we got some decimals. So what are we going to do with that? Well, what is my change in y? Oh, look at that. I forgot to tell you. Hey, look, I have a y-intercept. Beautiful. I know now that it's... Oh, and I should have said f of x up here. I should say f of x equals something times x plus 1.8, because that's my y-intercept. Okay, so that's good. Now I need to find my slope. Looks like going up 0.3, up 0.3, up 0.3, up. And this one's going up 1, up 1, up 1. So it's 0.3 over 1, or just 0.3. So I just say, oh, it's 0.3. Voila, I'm done. Okay, so we did a lot. We wrote equations, we evaluated functions, we identified linear functions, all sorts of fun stuff. We graphed. So that's what this section is all about. So good luck with that. M squared signing out.